Hello everyone, this is a video lecture for College Algebra, Math 1414, Section 3.4. I guess we're finding zeros. That's a good title there. Finding zeros of polynomials. Let's start with possible rational zeros. Possible rational zeros. And that's a long title. I'm going to do possible rational zeros, PRZ. And I'm going to give you a formula for this if that's okay. It is factors of the constant term, no, that's close enough, divided by factors of the leading coefficient. Leading, well, you know what I said. Leading, it's close. Coefficient. Okay. By factors, what do I mean? I guess I mean like just numbers that multiply to make that number. There you go. So it's kind of like basic factors. We're not talking, when I say factor, you're thinking something like this. I'm not thinking that. I'm thinking like what numbers multiply to make an 8? And you're like, oh, let's 1, 2, 4, and 8. Because 2 times 4 is 8, and 1 times 8 is 8. That kind of stuff. Okay. Now that we clarified, what is possible rational zeros? It's possible zeros. Cool. Now, rational just means that it's the ones that are able to be a fraction, I guess. And by fraction, I also mean divide by 1. So whole numbers and stuff are okay as well. I think the best thing to do is just to do it here. So 3, 4, 3. I got f of x is equal to negative 3x to the 4th minus 19x cubed plus 6x squared plus 8x plus 6. Whew. Find the possible rational zeros. So this is actually super easy. Factors of the 6. That's my constant term. Factors of the 6. 1, 2, 3, and 6. And then, hey, what are the factors of the 3 right here? 1 and 3. Now, pause. Notice that I'm putting a plus and minus all over the place because it could be to get a positive 6. I could have a negative 1 and a negative 6, or a positive 2 and a positive 3. Yeah. So there's all these different positive and negative combinations that are possible. I'm not really concerned if it's negative or positive. I just want the number. So leading coefficient is this guy. Constant is that guy. None of the other numbers even matter. Literally nothing else matters at this point. So they want the possible rational zeros. So we have this cool big list here. And now what does my math lab want? It wants you to write it all out. I'm going to distribute my denominator. So everything gets divided by 1, which is just itself. Ew, that was an ugly plus sign. Okay. And then everything gets divided by the 3. Well, so we got 1/3, 2/3, 3/3. We already have that. It's 1. And then 6/3. That's 2. We already have that as well. So this is our list. That's good. But it's still not good enough. I mean, maybe it works. My math lab is updating it technically itself all the time. So you could try that and see if it works. I just remember that the plus and minus doesn't always work the exact same way they think it is. So just in case, I'm going to show you the other way. 1, negative 1, 2, negative 2, 3, negative 3, 6, negative 6, 1/3, negative 1/3, 2/3, negative 2/3. That is also a good answer, okay? There you go. Cool. What you're looking at are the possible zeros. Yes, possible rational zeros, but possible zeros. If I wanted to start looking for, like set this equal to 0, solve for x. If I want to start solving for x for this original one, do you think that 5 is going to be an answer? No. What about 7? Could 7 be one of your answers? No. What about 2? Could 2 be one of your answers? Yeah. 2 could be an answer. What about 3? Is 3 one of those possible answers? Yeah. Yeah, 3. 3 could be one of my answers. What I'm doing is I'm shortening down a list that is infinitely long down to something that's much more shorter. So you're never going to try 100. You're never going to assume 10 works here. You're never going to think that an 8 is okay because they're not part of your list. Only look at stuff that is part of your list. That's the point. And what you're doing is you're making it much quicker. Now, this is interesting because I basically just say, well, that was fun and all, but let's go and do something else. So this will be a brand new problem and has nothing to do with what we just did. Isn't that just awesome? And then after this problem, we'll go back and do some more problems like it. So just a warning, this is your first kind of questions in my math lab, and they're not hard. But then it gives you this crazy problem, and then it'll go back to normal stuff, okay? I like to call this the backwards problem, because it's completely backwards from what we will be doing for the rest of the section. So I don't know why you think it's going to be backwards, because you don't even know what forwards looks like right now. N equals 3. I'm just doing the homework here with you. I got 3 and 4i are zeros. Okay. And they say f of -1 is equal to -136. What's f of x? There you go. Solve. Go. Figure it out. I'll wait here. You know what? You could pause the video and I'll wait here. I'm joking. Don't do that. Let's start to figure this thing out. When they say these are zeros, I got x is equal to 3. X is equal to 4i. But do you remember something about i's and imaginary numbers? They always come in pairs. So then the other one that you must have is -4i. You have to have both. You can't have just one of these to make this thing work. Now I'm going to ask you a question. Do we have four zeros? Do we have a degree of... I said 4. My bad. That's a 3 right there. Do we have 3 zeros? 1, 2, 3. Yes. That's my point. We're going to get x cubed plus blah, blah, blah in the end. That's my goal, okay? 3. So we got 3 zeros. We're going to get an x cubed. All right. Well, what I want is to actually get what f of x is. I have these answers, and I need to solve for f of x. And this is kind of crazy. I mean, again, we're looking for x cubed plus blah, 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 blah. That's a really big thing there, and I have no clue where to even start. Well, they gave you the answers. So now we're gonna find the question. We have the answers. Let's go and find the question. So what I want to do backwards-wise is find the factors. And notice what I'm doing is I'm just changing their sign. Okay, those are my factors. And they are literally all multiplied together. Now, just to be more technical in a mathy sense, this is your answer. You're done. That's it. That's your answer. My math lab does not like that answer. It's not simplified, but mathematically, that's your answer. Now, let's actually keep going. Let's simplify this thing. Notice that we can FOIL these guys together. Combine them, FOIL, something like that. Okay, so let's kind of do that, okay? X times x is an x squared. X times a 4i is a positive 4xi. I got a negative 4i is a negative 4xi. And then finally, negative 4i and positive 4i make a negative 16i squared. And this is just this one term. We still have this guy over here we haven't even touched yet. Well, these terms cancel. Notice that you have an I squared that's actually equal to -1. And so what we are really saying is a -1 right here. This is the formula for that. Here, I'll even write it up. I squared is equal to -1. Just like I is equal to the square root of -1. Wow. Of course, when I simplify even more, 2 negatives make a positive 16. And then I need to keep simplifying. So I want to FOIL this thing out a little bit more. X times x squared is x cubed. X times the 16 is the 16x. Negative 3 times x squared is negative 3x squared. Notice that I kind of put it into correct order because the order was going to be all messed up. What's 3 times 16 is a lot? 48. Negative 48. I looked at my paper for that one. Okay. This is your answer. That is your answer. And I type it in and it goes, eh. You're wrong. I'm shuffling my papers here. Not in distress. So I'm being serious with you. That is your answer. We did what they wanted. We went backwards. We found f of x. But there's some problem here that I haven't checked yet. I haven't double checked it yet. Let's go back up to the top. Let me just remember something. So we did this n equals 3. Did I get it at x cubed in the end? Yes. So we're good. Did we have 3 zeros? Yes. So we're good. Okay, cool. Did I use these guys? Did I actually use them? Yeah, I did all that. That was great. What about this one? Did I do anything with this one yet? Nope. This is your double checker. That's how you're going to double check it to see if you're right. I mean, we just typed it into my math lab and it said you're wrong. Well, I mean, maybe there's something up to this double checking thing. I don't know. So I'm going to go and plug this in. Notice that we got x is negative 1, right? X, f of negative 1. So x is negative 1 is equal to negative 136. And so I'm going to say x is equal to negative 1. Here we go. I got negative 1 cubed minus 3 times negative 1 squared plus 16 times negative 1 minus the 48. And this should be equal to negative 136. Should. So I got 3 negatives. I got 3 negatives total here. 2 plus 1 makes a 3 right there. So you'll end up with a negative. You get 1 negative, and you get a negative right there still. Putting this all together, I got, what, 50, 53? Was it 53? No. 60-something? Calculator. Okay, hold on. Whoa. 16, not 1. Psst, duh. Yeah, we're not going to get the... Yeah, you were screaming at me. Hey, where's the 16? Exactly. That was my bad. So we got a 1, we got a 3, we got a 16, and we got a 48. And I got negative 68 out of this. Negative 68. I was supposed to get a negative 136. No wonder it's not working. My double check is not working. Where did I mess up? Well, you didn't mess up. The thing is we are trying to get to this 136. And you know, 136 and 68. I just have this feeling. Hold on. Just like looking at this thing. What if I said 2 times this negative 68? Wouldn't I equal a negative 136? You see, this is what I got. This is what I want. And to get that, I need to multiply by 2. That's it. I just need to multiply by 2. I need to take my function and multiply it by 2. Now, this is a bad notation in a way. It's not really that bad. But I'm saying what we had originally, I'm going to multiply by 2. I'm going to say whatever I had, that would be my x cubed minus the 3x squared plus the 16x minus the 48. If I take all that and I say times 2, I should be able to yield the correct numbers that my math lab is wanting. And it just so happened that I needed to multiply it by 2. Everything by 2. Everything gets a 2. 2x cubed minus 6x squared plus 8. Nope. Isn't that 30-something or other? 32? Hold on. Yeah, 32. Yeah, 32. X. And then 96. 96. Okay. That is now your final answer. You put it in and you're correct now. So this is good. All right. So let's recap. I'm just going to recap this problem, okay? Because this is a big one, and you'll never see it again. N equals 3 says that we should get x cubed in the end, and we should have 3 zeros. Right now, they're only giving us 2. Well, we got to have the third one because there's going to be imaginary numbers always have a pair. And so I say, you know what? That's pretty good. I can make my factors. I can simplify, and I get down to something that is pretty nice. I like this guy. He makes me happy. And I'm going to tell you, sometimes in my math lab, you're done. Sometimes that's it. You are done, and you don't have to do any other math. Not in this case, and that's okay. So I need to double check before I actually say, like, oh man, am I done? I need to double check, of course. They give me something to double check with, so I say, okay, I'm going to plug it in, see what happens. And I don't get it. Oh no, I don't get your number. But you know what's funny is all I need to do is multiply by 2. So I'm just going to be a little tricky here and sneaky, and I'm just going to say whatever I had times 2. That's just kidding. Just kidding. I just wanted a 2 in the front. Just kidding. That's a thing, right? People say that. So I'm saying multiply by 2, and there we go. Boom! And it works. My way is definitely not professional. If you went and did the help me solve it and all that kind of stuff in my math lab, they'll give you a more professional answer. So I'll let you do that if you like, but my unprofessional answer is okay too. Okay, next number. Or next problem, f of x is equal to x cubed minus 5x squared minus 17x plus 21. And they say equals 0, solve for x. That's it. Go, figure it out. All right, well, I don't know even where to start. And think about it for a second here, but just between you and me, couldn't you just, like, put that into Desmos and graph it, you know? Couldn't you just go to your calculator and start finding out where the zeros, the x-intercepts are? Yes. But you're not going to have that on an exam, right? I mean, the idea is that we're trying to train you to not have calculators on exams here. You're in Math 1414. And so the point is that, yes, that's available to you, but I'm training you to not do that. So let's continue on and train to not have a calculator to help us here. What do? Well, I'm going to actually start with that possible rational zeros again. I want to know what possible numbers could there be out of the list of, I don't know, negative infinity to positive infinity. So factors of the 21, I got 1. What's the factors of 21? We got a 3, we got a 7, and we got a 21. What are the factors of 1? See that invisible 1? Just 1. And so that's my list. I guess if you really, really wanted to, you can list it out. Sometimes my math lab asks for it. Sometimes they don't. But there's your list. There you go. There's my list. And what I want to do is I want to just try some numbers. Just guess. I'm going to try. I'm going to plug in. I'm going to synthetic division with each of those. Now here's the thing. Could I just plug in one of these numbers and see if it works? Right? I plug it in and blah, 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 blah equals 0. Yes! That's what I'm looking for. I'm looking for zeros. That's what they're called, zeros. And so if I get a 0, we're good. And I totally agree with that. But it's not going to help you reduce this thing down anymore. You want to make it easier. So I'm going to use synthetic division instead, and it's going to give me a better result for the next time. Let me demonstrate. I'm going to pick a number. I'm going to want you to pick a number. And you pick 1. Okay, 1. Let's do it. It's a great number to start with. 1. We're just trying stuff out here. 1. And so I got 1, negative 5, negative 17, and then a positive 21. Now, this is good enough for synthetic division. I'm pretty sure we already did it. But what I want to do, yeah, that was like the last section. But what I want to do is, again, I want to say this is x cubed, x squared, and x. And we're going to find out what my synthetic division says for this. So I got 1 times 1 is 1, minus the 5 is a negative 4. 1 times negative 4 is negative 4. With this makes a negative 21. And so I got a negative 21 with a 21 makes a 0. Oh my goodness! X equals 1. That is so cool because I wasn't expecting it to be so easy. It was the first number. Wow. Yeah, it was just the first number. That is pretty easy. Okay. Cool. So x equals 1. That's one of my answers. They say x equals what? And you're going to start putting the numbers 1. But notice now that we had an x cubed, this is now an x squared. And if I rewrite it, I got x squared minus 4x minus 21 is equal to 0. And I want to say, you know what? I bet we can factor this thing. What two numbers multiply to make a 21, but add up to 4, and it'd be 7 and 3, so negative 7, positive 3, and therefore my other answers are 7 and negative 3. There's your 3 answers. You should get 3 answers because you started with an x cubed. So here we go. 7, negative 3. There's your answers. All it is, you're done. That's the end of that question. You're done. That was super easy. Cool. Now, was 7 part of your list? Yeah. Was negative 3 part of your list? Yeah. Do you see how they're all in this list, right? And there's extras in the list, of course, that we never had to use, but that's fine. Let's keep going. Another one. 3, 4, 41. 4x cubed minus 12x squared minus 9x minus 1 is equal to 0. Solve for x. Okay. What's my possible rational zeros? So the factors of the 1 are 1. Factors of the 4 are 1, 2, and 4. And so my list, if I wanted to list it out, everything divided by the 1, then divided by the 2, then divided by the 4. So I got 1, negative 1, 1 half, negative 1 half, 1/4, negative 1/4. So that's my list. Now let's start testing. Pick a number from this list that you want me to start doing. Pick a number. 1. Exactly. I mean, did you want to start with negative 1/4? You could. And I'll see you in a couple minutes, but I'm going to try the easier numbers first. 1 times 4 is 4, minus the 12 is a negative 8. 8 and 4 makes 12, yeah. Negative 8, negative 9 makes a negative 17. Negative 17, nope. I wanted a 0. I don't care what I got there. It's not 0. So that was no good. This is not a good number. Let's try a different number. What's another easy number up here? Negative 1. Exactly, negative 1. And I'm just going to see if this works. I mean, some of these numbers work. They got to, right? I got a negative 4, negative 16. 2 negatives make a positive. 16 with the 9 is going to make 7. Negative 7. Nope, that didn't work either. Oh, no. We got to do fractions? Yep. Turning my page here. What's a good number that you would want to do? Negative 1/2. Wow. You just wanted to skip 1/2 entirely? Yes. Okay, good. It wouldn't have worked. I looked at my notes. You can skip around. You don't have to go sequentially. Just pick a number that you like. And so negative 1/2 with the 4 it would make a negative 2. And then so I got negative 14 out of that. 2 negatives make a positive. Half of 14 is 7. So I got a negative 2. 2 negatives make a positive. 2 over 2 is a 1. We got it! X equals a negative 1/2. That's one of my answers. That worked. And then let me see what we have left over. I got 4x squared minus 14x minus 2 is equal to 0. Looking at my leftover equation there. So, let's factor. What two numbers multiply to... No. I mean, you can. It would just take forever, maybe. Is there an easier way to start doing this? Well, you could keep going with the synthetic division. That is another possibility. But I just don't think that's going to be helpful in this case. So what I would rather do is I want to do quadratic formula. Why quadratic formula? No, don't think like that. I was just joking around. Quadratic formula because it's going to give you the answers immediately. Even if it takes a whole minute to do. Get comfortable with it because we'll be using it a lot. No, I'm playing. Just plugging it in. We've done this before. Nothing new here. Just plugging it in. 2 negatives make a positive 14. 2 negatives make a positive 14 squared. I actually don't have that on my paper. No. Yes. There you go. And then we got 2 negatives make a positive again. 16 times the 2 is 32. And then all divided by 8. You might be wondering, hey, couldn't I factor out a 2 from all these guys? Yeah, but that's not going to help you. If you go and do that, you'll get this guy here, and I'm still going to ask the question, what 2 numbers multiply to make this thing work? And you're still going to be stuck. It's not going to work. So that is a possible way to do it, but not required. That's what I did in my notes for a little bit. That's why I have a slightly different answer here, but that's okay. We're going to get to the same goal in the end. Okay. So that is my answer. Yes. And if you type that in, it'll say, great job, but it's not simplified enough. So we have to do more to it. And so what do I need to do is I need to take that 228 and I need to break it down to prime factors. So do we have a 2 in there? Yes. I got 1, 1, 4. Do I have a 2 in there? Yes. I got a 57. Do I have a 2 in there? No. Do I have a 3 in there? I think so. Yes. And honestly, I think that's good enough. I don't foresee anything else here. Like 19 is prime. So these are my answers. And I'm going to rewrite now the inside here. 14 plus or minus the square root of 2 times 3 times 19, all divided by 8. Of course, what I want to do is I want to pull out the pairs. Let me even say that. Pull out the pairs. And so what I actually have now is 14 plus or minus 2 times the square root of 3 times 19 on the inside. So if you see a pair of numbers, doesn't have to be a pair of 2s, it could be a pair of 5s or a pair of whatever. Pull out the pairs to a single number in the front, and then you just keep on going. We're almost there. The inside actually returns back to a 57, which we kind of already had. I think on the outside we all have a 2 somehow. So you can cancel a 2 with every single term. That's the quickest way to do this. Everything gets canceled by a 2. Or you could, distribute denominator and all that other good stuff. There you go. There's your other 2 answers. And so my final answer, if you remember way back there, I had -1/2 at some point. And then I have this 7 plus the square root of 57 over 4. And then I have the negative square root still divided by the 4 there. And there we go. Awesome. Cool. We got more. I would say, okay, do you have any questions? But you can't reply. But you can email me. We can always talk about that. That 3 just doesn't look very good there. And there we go. Okay, so I got this crazy thing here. First off, I want to do the possible rational zeros. What are the factors of 26? 1, 2... Is there a 3 in there? I don't think so. Maybe. No. Is there a 4 in there? No. Is there a 6 in there? No. Well, what is in there? 20. Is there an 8? Is there a 7? Is there a 9? Is there an 11? Well, I know it's 2 and 2 and 13. Is that it? I think that's it. Okay, well, there's my list. I expected something else, but I guess I was wrong. There we go. So we have my list, and of course divided by 1. Everything's just going to stay the same. So there's my list. Let's start trying numbers. What's an easy number that you want to pick from this list right here? What do you want to pick? 1. Good. That's an easy number. I like easy numbers. 1 times 1 is 1. -7. -7 actually cancel, make a 0. That's kind of funny. And anything times 0 is 0. 42, 42, not a 0. So that didn't work. -1. Good, good, good idea. I like -1 as well. -1, -9, +9, 16, -16, calculator. 26. -26, 0. We did it, we did it, yeah! Woo! There it is. We got our answer. So this went from an x to the 4th down to an x cubed. And so I can rewrite this guy as x cubed minus 9x squared plus 16x plus 26 is equal to 0. Okay, now what? Pick another number from the list. Still cubed. You can't factor that yet. You got to keep going. It's a really big problem. What's another good number from that list? 2, 13, 26, blah, blah, blah. Let's try -1 again. And you might be wondering, again? Why are we trying it again? And again with the new numbers. 1, -9, 16, 26. Why -1 again? The reason why is because it could work. Boom! See, it did. It happened again. What does that mean? If you have 2 of them, you actually have a multiplicity of 2. Oh, it's a touch point. It touches the x-axis. Okay, so this was x cubed. Now this is x squared. And I think I can factor this thing, x squared minus 10x plus 26. Okay, what 2 numbers multiply to the 26, but then add up to the 10? Dun, 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 dun. Nothing that I can think of. So what I'm going to do is quadratic formula again. So I'm going to plug in everything just like last time. I'm guessing I don't have to remind you of that formula every single time. You kind of get what I'm doing now. This is just a summary. That's all it is. Oh, we already squared it. 4 times 26. 104. Okay. Uh-oh. I'm getting kind of nervous. Uh-oh. Uh-oh. So we got -4 inside the square root. You can't do that. It's not going to work. Well, hold on. Don't I remember there's something with a negative square root? Yes, I know you're screaming it at me. I. What you're doing here is you're saying a negative inside the square root? No. Let's get it outside. Call it an I. And then just keep on cruising. What's the square root of 4? 2. What do all these numbers have in common? They all have a 2, so you can cancel a 2 with each number. So you get a 5. And, well, that would be a 1. 1i, I guess, divided by 1. Clean it up a little bit. 5 plus or minus 1i. Those are your other answers. So final answers, what would you put in my math lab? We had the -1. We had the -1 again, right? And then we had the 5 plus or minus I. You can use the plus and minus still. Just, be careful as you go through using fancy buttons. I don't know if this works or not, but I do know that you can remove it. Like I have on my notes to just, you have a multiplicity of 2. Yes, good job. But they don't really care about that here. They're just saying, give me the numbers. Well, -1 and then these other guys, that's the technical correct answer. Okay, I thought that would take a lot longer than it did, but these are just really big problems. So I don't think I skipped anything either. Yeah, we did it. So this is a very big section, honestly. I did not do all of your problems at all, not even close. But they're all very similar. They have that same design. So if you have a question, of course, send it in to me. We'll talk about it. That's fine. But I think I'm done here. So that's it. Thank you very much. Have a great day.